By this point, we've seen a number of different factoring methods, and it can probably feel a bit confusing to try to remember which ones to use when. This section is going to focus exclusively on that. Now, there is one uniting thing you want to do no matter what, which is that if you see a GCF, if you see anything you can factor out of every term, always factor it out first. Usually, just doing that will tell you exactly what you need to do next. Now, anytime you have two terms, if you'll remember, that's when we use the difference of squares, or we use the sum and difference of cubes. You'll usually recognize the difference of squares because it'll look like a squared minus b squared, which, if you will remember, factors into a plus b times a minus b. As for the sum and difference of cubes, well, a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared, and then a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. And remember, if you see the sum of squares doesn't factor, so watch out for that. If you see three terms, there is the possibility that you're dealing with a perfect square trinomial. If you'll remember, a perfect square trinomial looks like this. If you have a plus or minus b squared, that is a squared, whatever your sign is, 2ab plus b squared. What happens a lot more often, though, is that it'll actually just be something where you have to do regular garden variety factoring. You'll have to use the reverse FOIL method, or what I called, when I covered it, the product sum method. If you have four terms, what usually works here is to factor by grouping. Okay, let's take a look at example 1. Example 1 has two terms, which suggests that we'll be looking at something around here. Those two terms are both squares, so we're going to do the difference of squares there. So the difference of squares is what you want to use here. This turns out to factor into 5x plus 4 times 5x minus 4. As for example 2 has three terms, and if you notice, we don't have any squares there, so instead we're going to use the product sum method. And if you do use the product sum method, try it yourself. You should discover that you get x minus 5 times x plus 4. As for example 3, that has four terms, which suggests that we're going to factor by grouping. If you'll remember, that means we look at the terms in pairs. I can factor y out of the first pair, I get x plus 2. I can factor 5 out of the second pair, I get x plus 2. And so this whole thing becomes y plus 5 times x plus 2. So again, when you're factoring, first look at the number of terms. And most of the time, that will tell you what you need to do next.